The got it question in part 5. The picture shows the jump of a dolphin. Now suppose the path of this jump changes so that the axis of symmetry becomes x equals 2, but it stays at the same height. If the path of the jump also passes through 5, 5, what is the quadratic function that would model the path of the jump? Well, you're going to do the same thing. The only difference is going to be your vertex is new. So they said the height is at 2. Alright, so we're going to do 2 comma, what was it last time? 7. So we do 2 comma 7, and that's our vertex. And if you go over here, you can see that at 2 comma 7, that is where the maximum is. Plus the fact that they told us that x is 2 and the height stays the same. Now they were nice in this problem when they gave us the other point of 5, 5. We're going to go through the same steps we did before. Alright, we have the two most important things. Now we really have to solve for h, k, and a. Remember that h and k are easy and that a takes a little bit of work. Step 3, write the original, kind of the generic formula of vertex form. Y equals a times the quantity x minus h squared plus k. Plug in what you know. Well, I'm going to plug everything in all at once here. Remember that 2 is h, 7 is k, because those come from your vertex, 5 is x, and 5 is also y. Alright, so this is going to become 5 equals a times the quantity. X is 5 minus h is 2, square it, plus k is 7. Keep filling in. 5 equals a times 3 squared plus 7. I just did 5 minus 2. 5 equals 9a, because 3 squared is 9, plus 7. Subtract 7. Negative 2 equals 9a. Divide by 9 and reduce. Negative 2 over 9 equals a. We now have h, k, and a, and we can write our final answer. Y equals, fill in a, negative 2 over 9 times the quantity, and we're putting this in vertex form. X minus h, so x minus h was 2, quantity squared, plus k, k was 7. If you want to be real fancy, you can write it in function notation and write f of x equals. Not necessary, but it is in function notation.